So we've had a little bit of practice with applications of systems of equations and inequalities in our notes. And now on the classwork, I want to give you guys just a little bit more help with some of the more tricky questions that we have. And so I'm going to go over a few of them. Number 2, number 7, and number 9. So make sure you have yours up and your Desmos as we go through this, so that way any questions you have, I might end up answering. All right, so let's look at question 2. Before I do that, though, I want to change my settings on my Desmos. I'm going to turn on projector mode and my arrows. I like reverse contrast. You guys don't have to do that, but I'm going to turn that on. All right, number 2 says, Tim and Kevin each sold candies and peanuts for a school fundraiser. Tim sold 16 boxes of candies and 4 boxes of peanuts and earned $132. Kevin sold 6 boxes of peanuts and 20 boxes of candies and earned $190. Find the cost of each. Now, at face value, this doesn't seem too difficult, but the wording here is just a little bit not what you would expect, and that's where I see a lot of students making mistakes on this one. So when we go to set this up, our first step is to read it and make sure you understand it, which we just did. Our second step is going to be to identify our variables and assign them if we need to. Everybody likes to use X and Y, so I'm going to continue to use X and Y. Let's make our X the first thing we see that we know it's going to be. We're looking for the boxes or the cost for candies and the cost for peanuts, and it kind of tells us that in our answer choices here. So we'll make candies our X and peanuts our Y. And if you don't have a pencil and paper to write this down, I strongly recommend you have some. If you don't have any pencil or paper handy, you can open up Cami and take your notes that way. So we have X for candy and Y for peanuts. All right. Now remember, we have X for candy. That's going to be important, and Y for peanuts. We have to follow through with those variables in this entire problem. Okay. So now that we've done those first 3 steps, we're going to write out our system of equations here. Okay. So we have 16 total boxes of candies, or yeah, 16 boxes of candy, and 16. And then we have our X, which we said was going to be candy. So 16X plus 4 boxes of peanuts. And we don't know the cost of the peanuts, so that's going to be 4, oops, plus, I'm sorry, plus 4y. And then it all totals 132. So it's going to be equal to 132. That's our first bit. And let me zoom in on this Desmos a wee bit. All right, that's good. And then for the second one, it says 6 boxes of peanuts and 20 boxes of candies. I've seen multiple students uh, get confused and put the wrong variables for these. They put 6x plus 20y because we think that x is coming first, but x goes with the candies. However, the first thing that shows up is the boxes of peanuts. So we're not going to do 6x plus 20y. Instead, this will be 20x plus 6y. If you want to do 6y plus 20x, that's fine because addition is commutative. All right, and then we have that all equaling $190. And since we're trying to find the cost, if you go into this thing, you try to hover over it, it's going to be kind of difficult. It's probably best if you click it. When you click on it, it gives you the intersection between the two of them. And so that'll be the answer that you get. If you try to hover it, you may get it a little off. And remember, our x value is the x coordinate pair. That's the price for candy. That's the variable we assigned initially. Then our y value is going to be this 25. So the cost for a box of candy is $2, and the cost for a box of peanuts is $25. Now, a couple students were asking about the dollar sign. You don't have to put that in, but if you do put it in, it should still count it correct. All right, next question we're going to go over is number 7. If you have any questions on this one here, definitely come back to the Zoom chat and ask, and I will help you. Number 7. Number 7 says, Bob bought 8 hockey tickets for $59. Adult tickets cost $10 each, and children's tickets cost $3 each. How many of each ticket did he buy? So, how many adult tickets did he buy, and how many children's tickets did he buy? So, just kind of at reading the question and looking at the thing, it gives us our first 3 steps. We've read the question, we can assign our variables: X for adult tickets, Y for children's tickets, and now we just have to set up the system of equations. All right, so with this, this one may be a little bit confusing because we don't have it listed out as easily as we did for number 2, but all the information we need is here. I'm going to start with the easiest of the 2, just because that's where I feel like a lot of students will start. It says adult tickets cost $10 each and children's tickets cost $3 each. And since we know that he spent $59, 10 times the price of the adult tickets, or 10 times the number of adult tickets plus 3 times the number of children's tickets gives us our first equation. So 10x plus 3y is going to be equal to 59. And then, Mr. Williams, how do we get that last thing here? We know he bought 8 total tickets. He bought some number of children's tickets and some number of adult tickets. This number plus this number, it's got to equal 8. And that's where we get that last one from. Okay, that last equation. So x plus y equals 8. All right, and so initially it seems difficult just because the information doesn't seem like it's right out there, but everything we need is given. And then we see our intersection is right here. And when you go to click on this, if you guys notice, if I click somewhere that's not on my intersection, it gives me a gray dot. It doesn't give me the white dot that indicates that it's an intersection or my solution. When I do have my solution, it's white and bright and easy to see. So here we see we have 5 adult tickets and 3 children's tickets. All right, let's go on to the next one. Question number 9. This one says, you work a maximum of 40 hours a week. You need to make $400 in order to cover your expenses. Your office job pays $12 an hour and your babysitting job pays $10 an hour. How many hours could you work at each job to make at least $400? Hint, set up your system, then plot each answer to see if it's a solution. All right, so we just read it. Our variables are kind of embedded in the question. Number of hours at our office job is going to be our X, and then number of hours at our babysitting job is going to be our Y. And then we need to set up our system of equations. Excuse me. There's an easy way that we see one equation set up pretty easily, but the other one seems a little bit confusing. So I'm going to start with the easy one first. All right, so it says your office job pays $12 an hour. How many hours are you working? I don't know. That's what we're trying to figure out. So we're going to have a 12x plus the babysitting job, which pays $10 an hour. We don't know how many we're working there. There goes that y. And then we want to figure out how many hours we're trying to make to save at least $400. Okay, that at least tells us we're going to be using an inequality. Can we make more than $400? Absolutely. But we need a minimum of $400. So that 12x plus that 10y needs to be greater than or equal to that 400. And then to pick out that next bit of information, it tells us in the first sentence, we work a maximum of 40 hours a week. 40 hours a week. So however many hours at one job plus however many hours at another job, it will not be more than 40. And here we have X for our number of hours at our office job plus Y for our number of hours at our babysitting job. It has to be less than or equal to 40, because we're not going to work anything more than 40. We can work less than 40, but we won't work more than 40. And when we type this in, we get this really weird looking set of system of equations. To do the rest of this problem, and this one may be a little bit tricky, just because the way the question is set up. Once we have these things in here, our next thing is going to be to apply each of these. Okay, I'm not going to go and do all of that for you all, but you can do that part yourself, and that's an easy part. Now this is set up to uh, accept all the correct answers, and if you put incorrect answers, you'll get the question wrong. Okay, so once you've got this set up, the rest of it should be relatively simple and easy for you all to do. If at some point you run into any questions, let me know. Come back to the Zoom chat, ask them, and I will do my best to help you. And then you all can move on to the next thing when you finish with the classwork. All right.